So this video is dealing with Newton's first law and what happens to an object when the forces acting on the object balance out. So first of all, Newton's first law says that an object continues in a state of rest or uniform velocity or uniform motion unless acted upon by an external net force. Now let's investigate what that means using this phet simulation. Now there'll be a link in the notes that shows you where to go so that you can download this yourself and then play around with it and see. So first of all, let's start with the situation that we're probably more familiar with. If you've got an object and you exert a force on that object with equal size to the left and to the right, what will happen to this object? It will stay perfectly stationary. If the object was stationary to begin with and you exert a force of, just take values at the top here so you can see, if you exert a force of 50 newtons to the left and 50 newtons to the right, that object would keep perfectly still, it would be stationary, there'd be no net force on it. In other words, the forces balance out and this thing wouldn't move at all. So that's the first part of Newton's first law. He says that if an object is stationary and the forces on it are balanced, then the object would keep stationary. The second situation, you can just click the little options at the bottom here. The second one says motion, we go to the one that says friction. And then just tick here, you want to see all these values because you want to get an idea of what's happening here. Now the second situation is this guy is going to push this box, there's friction on the surface, and if his force is bigger than the frictional force, you can see the values there, then this object will accelerate. You can see on the speedometer, this object is actually accelerating. So if there is a net force, you call this the net force. In other words, the bigger minus the smaller force gives me my net force. If there's a net force, the object will accelerate. That's crucial. The object will accelerate if there's a net force. If there's no net force, let's say the object was moving, okay? So there's a net force to the right. In other words, the bigger force is to the right. If the force that he exerts on the box and the frictional force become equal, I think this is as close as we can get it, notice that the object doesn't stop. It's not like the first situation. This object was already in motion and now the force is equal to each other. What will happen then is the object will keep moving, but it will move, if you look at the speedometer there, it will move at a constant velocity. In other words, it won't accelerate if the forces are perfectly equal to each other. So that's the second part of Newton's first law. So either the object will stay stationary if it was stationary to begin with and the forces balance out, or if the forces balance out and it was already in motion, it would keep moving, but it would move at a constant velocity. In other words, it wouldn't accelerate. The acceleration is zero. If your acceleration is zero, it means you're going the same speed every second. You're not going faster or slower every single second. So two parts to Newton's first law.